All right, welcome to day 9, our second review day for this unit. Today we will be reviewing the proof portion of the unit. So you can be putting in your planners just to study for the test. Now we will be doing 3 proofs together, and then there's additional proofs in the review pages that the worked out answers will be on Schoology. So any additional time in the period after this video ends, you can be working on those. And tonight as you're studying, you can be working on those as well, and then checking your answers on Schoology. So the ones from the algebraic that we did not do together last class, starting with number 2. So our diagonals bisect each other in a parallelogram. So AE and EC should be congruent because segment bisector implies midpoint, and then midpoint implies 2 congruent segments. So set those equal and solve, you get x equals 8, and that's all they wanted us to find. Number 3, we got rhombus. We're working with those angles, angle 1, angle 2 they told us was 5x minus 1. And then SPQ, the big one there, they told us that this big angle was 12x minus 24. Well, in a rhombus, diagonals bisect the angle. So if angle 2 is 5x minus 1, we can also call angle 1 5x minus 1. And when you put those together, they should be the same as the SPQ. So we can do 5x minus 1 plus 5x minus 1 equals to 12x minus 24. Go through and solve, and you get x is 11. But that's not what they wanted. They wanted to know the measure of angle 2, so we fill that 11 back into the expression for angle 2, and we eventually get 54 degrees. Number 4, we got a parallelogram. We are working with A, B, and CD. Parallelogram implies opposite sides congruent. So set those expressions equal to each other and solve. We get x is 3. But that's not what they wanted. They wanted CD, so fill the 3 back into its expression, and we get CD is 11. Next, we got parallelogram cats. When it does not give you a picture, draw the picture, label going around in the circle. So you might not have the letters in the same spots as me, but yours should start with C somewhere and then go around in a circle. Our 2 angles they talked about, A and S, ended up being opposite angles. Parallelogram implies opposite angles congruent. So we'll set those equal to each other. Solve, we get x is 14. But that's not what we wanted. We wanted angle C. We'll sub in the 14 for x. For example, we get this is 60. We also have parallelogram implies consecutive angles supplementary. So angle C and that 60 should add to 180. So over on the right there, I did 180 minus 60 to get that angle C is just 120 degrees. And the last one you had to do on your own, number 6, again, draw the parallelogram, label around going in a circle. Angle L and angle O were consecutive angles, and in a parallelogram, consecutive angles are supplementary. Add those, set them equal to 180. When we solve, we get x is 24, and that's exactly what we wanted. So we're going to first do one from day 6 that we didn't do in class. So if we could go to page 30 in our packets. So flipping back several pages to page 30. We're going to do this proof first, and then we'll come back and do some of the ones in the review section. So let's go ahead and do our statements, reasons, and givens. You can either write those all in one given or do 3 separate ones. I just chose to do 3 separate ones. That's my preference. All right, so let's come up with a plan. We eventually want AD and BF to be congruent to one another. Well, BF is a side in a triangle. So it might not be a bad idea to first try and get that triangle. And so by that triangle, I mean this tiny triangle here. And this triangle here, let's maybe try and get those to be congruent to one another. So let's maybe start with that midpoint that we have. That's an easy one to do. We'll do midpoint, implies two congruent segments. If E is right in the middle of DF, then our statement would be that DE is congruent to FE. We said they're congruent in our proof, so let's mark it up in our picture. Well, we've also got a set of vertical angles there. I'm going to go ahead and label them 1 and 2. We can do vertical angles, implies congruent angles. And our statement would be angle 1 congruent to angle 2. We said they were congruent, so let's mark them up in our picture. So we have a side and an angle so far. Well, we haven't used the fact that we have a rhombus yet. Rhombus has 8 properties. It has the 5 parallelogram properties and then the 3 additional ones. Well, let's use that in a rhombus, opposite sides are parallel. So rhombus implies opposite sides parallel. We originally get that from the parallelogram, but rhombus has all of the parallelogram things. And eventually we're going to want to do a zigzag to get some alternate interior angles. So the ones that we really care about being parallel are the top and the bottom ones there. So we're going to say in our statement DC is parallel. And notice they told us as a given that ABF is one complete straight line. So we can actually say that it's parallel to ABF rather than just AB, so that it includes that part that eventually leads to the triangle. Well, once we have parallel lines, we can do parallel lines implies congruent alternate interior angles. So we have 2 options for doing a zigzag. I'm going to do my zigzag going this way, where 2 of the parts of the zigzag should be the parallel lines. And I'm going to go ahead and number these 3 and 4. So our congruent alternate interior angles will be angle 3 congruent to angle 4. I set them in my proof that they were congruent, so let's mark it in our picture with a different number of marks. Well, in both triangles, we have 3 things marked up. Notice we have a side in between the 2 angles. So we should have angle side angle congruent to angle side angle. And we'll get our triangles congruent, so name the first thing any one you want. So I'm going to go DCE for the first one. Congruent to. D had my 2 green marks there, so that's going to match with F in the other one. C is my angle that was not marked up. That matches with B in the other one. And then so that means we'd have FB, then E. Well, once you get triangles congruent, we can do congruent triangles implies congruent corresponding parts. Now, we might not know where we need to go yet, but we need to involve BF eventually. So let's do what we can get for BF. So let's do our congruent triangles implies congruent corresponding parts. And BF would match with DC. So we'll say those are congruent. And once we say they're congruent, we can mark them in our picture. So let's pause and see where we are and where we want to go. We eventually want to get AD congruent to BF. Well, BF is currently congruent to DC, which is a side in our rhombus. In a rhombus, we know that all sides are congruent. So, since we eventually want to get BF congruent to AD, which is also a side in the rhombus, let's go in that direction. Let's do rhombus. Implies all sides congruent. Or you can say 4 congruent sides, that's fine as well. And we could do all 4 of them, but the ones we really care about are DC and DA. Those are the ones that are going to help us out here. But if you're unsure, just list all 4 of them congruent to each other in a big string. And if I mark up DC congruent to DA now, so I'll put 3 marks on. Notice DC got marked up twice. By this point in proofs, hopefully we know when something gets marked up twice, that automatically tells us transitive. So we want the other purple and the other red one congruent to each other. So we're going to have AD and BF congruent. And that's just what we wanted to prove, and that's going to be by the transitive property. So that's just an example of one that we're given a rhombus, and we used some rhombus implies stuff to prove what we wanted to prove. All right, we're going to go over to the review pages now, and we are going to actually start with number 4 from the review proofs. So number 4 was on page 45. So if we could flip over to there, page 45, number 4. And go ahead, do your statements, reasons, and givens. All right, so we got angle 1 congruent to angle 2. Let's go ahead and mark those up. And let's see if we can come up with a plan. So we eventually want to show this quadrilateral as a parallelogram. The 3 most common ways we do that. We could do one pair of opposite sides, congruent and parallel, implies parallelogram. We could do both pairs of opposite sides congruent, implies parallelogram. Or both pairs of opposite sides parallel, implies parallelogram. Well, notice angle 1 and angle 2, if we did a zigzag this way, those are already congruent alternate interior angles. So let's do congruent alternate interior angles, implies parallel lines. And the ones we get parallel are AD and CB. And parallel, we mark up with our little arrowhead. And just note, that doesn't mean we have them congruent. That just means we have them parallel the arrowhead. But that's great. We've already got a set of opposite sides parallel. So that pretty much rules out getting both pairs of opposite sides congruent. We want to either get this same set of sides congruent or get the other set of opposite sides parallel. Well, let's take the given we haven't used yet. We've got segment bisector implies midpoint. The midpoint is whatever comes after the word bisects, unless they said they bisected each other, which they didn't say that here. So we're going to have E is the midpoint of AC. And next we should do midpoint implies two congruent segments. If E is right in the middle of AC, then that means that AE is congruent to EC. We said they're congruent in our proof, so we can mark them congruent in our picture. Well, we basically could work with those left and right triangles if we wanted. We already have two things marked congruent in there. So let's maybe get a set of vertical angles. Let's call these 3 and 4. We can do vertical angles implies congruent angles, and angle 3 is congruent to angle 4. Now notice I didn't mark them up yet, because you don't want to mark them up until you've said they're congruent in your proof. We've said they're congruent in the proof, so now I'm going to mark them up. Well, now our triangles are congruent because we have two angles in the side in between. So we can have angle side angle congruent to angle side angle. I'm going to call the first triangle triangle ADE is congruent to triangle. A was where that blue marked angle is. That matches with C. D is our angle that's not marked, so that matches with B. And then E is our last thing left. Well, we already had one pair of opposite sides parallel. Now that we have the triangles congruent, we can get any other things in those triangles congruent if we want by doing congruent triangles implies congruent corresponding parts. And the thing that would be helpful for our purposes is to get another set of opposite sides but congruent this time. So from those two triangles, we want to get AD to be congruent to CB. We said it was congruent in our proof, so we can mark them congruent in our picture. Notice we have one set of opposite sides now marked congruent and parallel. So we're ready to finish this off. We can say one pair of sides of opposite sides, I'll say, congruent and parallel implies parallelogram. And our statement will just be what we wanted to prove. ABCD is a parallelogram, and feel free to use our little parallelogram symbol instead of writing out the word parallelogram. All right, the other one we're going to do in this video is number 5 over on the next page. And we'll give you a minute to do your statements, reasons, and givens. So we want to prove it's a parallelogram. So our plan is to either get one pair of sides congruent and parallel, or do both pairs of opposite sides congruent, or do both pairs of opposite sides parallel. So if we mark up what we have so far, we've got SC congruent to DG, and we've got SV congruent to TD. So the fact that SV is congruent to TD, that basically rules out both pairs of opposite sides parallel. We either want to get that same set of sides parallel or get a set of the other set of sides congruent. Well, let's go with these perpendicular lines. Let's do perpendicular lines implies right angles. SC and TV meet up here, so we'll call those 1 and 2. EG and TV meet up here, so we'll call those 3 and 4. And we don't know which ones we will need, so let's just list them all. So we'll say angle 1, angle 2, angle 3, angle 4 are right. So next we'll automatically do right angles imply right triangles. Or not right triangles, right angles imply congruent angles, sorry. So we'll have angle 1 congruent to angle 2, congruent to angle 3, congruent to angle 4. We said they were congruent in our proof, so let's mark them in our picture. Well, notice the top and bottom triangles have 3 things in them already. We have 2 sides and an angle not in between. So we have SSA. Well, that one's no good. But if we notice, our A is a right angle. So we're going to still be okay. We can eventually get hypotenuse leg. So we're going to do right angle implies right triangle. And that'll be triangle SGV and triangle. If we went S to G, we would do D to G, then T. R right. Well, once we've said the right triangles, we can now say they're congruent by hypotenuse leg. So we'll have HL congruent to HL. And we'll say those triangles, which we were already careful about naming a second ago, that they're congruent. Well, now that we got the triangles congruent, we can get any other things in those triangles congruent. We already had the opposite sides congruent. We're kind of heading towards getting that same set of sides parallel. Well, to get that same set of sides parallel, usually we want to get a pair of alternate interior angles congruent. So a zigzag that would involve those opposite sides would be this, meaning let's label these angles 5 and 6. So we're going to do our congruent triangles. Implies congruent corresponding parts. And we'll have angle 5 congruent to angle 6. We said they were congruent in our proof, so now we'll mark them up in our picture. Those are congruent alternate interior angles, which we can now use to imply parallel lines. Congruent alternate interior angles implies parallel lines. The parallel lines are the two flat parts of our zigzag, so SV and TD, which we had already had congruent. We'll notice in 4 we have SV congruent to TD. In 10 we have SV parallel to TD. So we're ready to finish this off now. We have one pair of opposite sides, congruent and parallel implies parallelogram. And to finish it off, we'll just say what we wanted to prove. So we've got TDVS is a parallelogram. All right, so any time left in the period, you can do the other review ones. I would say maybe do 1, then 2, then 3, or 1, then 2, then 6, then 3 would be the order that I would suggest to do them. And those worked out solutions are posted on Schoology, so you can check those after you do them in class or later tonight when you are studying. And then next class will be our test. Have a great rest of your day.